It's the first time with OP Jindal University to give guest lecture. So I hope you'll be enjoying this thing. So I'll start with my presentation. So I'll share my screen.
Yes.
Uh, is my screen visible?
Yes. Can you put it in full screen mode?
Yeah.
Yes.
Okay.
Yes. Yes. We can start.
Yes. So actually, what we'll do, I'll turn off my video so you'll get proper. Or is it okay if we have a video?
There is no issue. You can proceed with this only.
Oh. So today's topic about AI-driven robotics and industrial automation. And again, we are moving ahead to the industry 5.0, which is web uh, 3.0, we call it as in industries. So which is like a dark factories or factories with unmanned, uh, which is fully automated factories connected with cloud edges and then operating and taking its own decision on the basis of conditions which we were giving to it. So before that, going to directly in AI-driven robotics or automation, there is one more word called metaverse, which is started buzzing like all around us. So on top of that, industrial metaverse is the terminology where what exactly we are doing in industrial metaverse, where fast engineering decisions are made and leveraged the precise and robust data from real and digital systems. So real means the plant data or shop floor data which is collected from the IoT or IIoT edge, and the digital data which we create from layout, simulations, then digital replica of those physical plants. So we'll leverage that precise and robust data to take a decision. Okay. Again, the place to collaborate, experience, and interact with the comprehensive digital twin. So by utilizing this comprehensive data, we can analyze by using our AI and machine learning models, and can we interact with this data and predict some of the predictive maintenance or quality of product and processes. So that is a place where we can collaborate with users and different computer generated digital files where we can take a decision to optimize our plant or the processes. Okay, that's what the visualizing the digital twin in the context, gaining insights in realistic environment. So whatever insights we are getting from the shop floor data, we are trying to replay those on a digital twin model and optimize and calibrate our model on the taking a best decision or giving us the prediction or the predictive maintenance strategies where we can optimize our resource utilization and maximize our throughput. Okay. So in these things, in metaverse, we are trying to collaborate our digital and real data to make a change, on our physical shop floor, where we can utilize the best of best thing from our resource utilization, which might be from man, machine, or robots. So that is the thing where industrial metaverse will be like big thing in the coming future. Uh, this is the evolution process, not a revolution, but evaluation. Like as we see from here, like we started with a 2D design, then again it became a 3D with different digital transformation tools, then 3D simulations along with the virtual HMIs where a human can interact with those dynamic 3D models. Okay, then multiple domain designs and where we have a model based simulation, then your product design simulation and production process simulations. So all those things from production to the performance of the product, we are going to have a design simulation of it. And then next part, I think we all have heard about the AR and VR. So again, MR is also coming into the picture, mixed reality. So whatever simulations or design which we have done, we can visualize those into the real immersive environment by using AR and VR, where we can take a fast decision, having a design reviews with different geographical locations. People can join those VR conferences and take a decision, optimize our designs and the simulation part of it. And the next part is IoT. We are taking the data. As of now, we are doing in virtual environment to optimize or calibrate our virtual plant. We're taking the data from shop floor by using IIoT or IoT. So we call it as a digital twin, where our data from our shop floor, we are taking it and trying to implicate onto the digital model of it. So where it called as a digital twin. So we'll have exact scenarios which we can face on the shop floor. Okay? And here comes the AI. So by generating those data, gather the data for different scenarios, and by using our AI ML model, we can predict some of the failures uh, or some of the bottleneck in our production line, or maybe in terms of production planning, is there any bottleneck or hurdles for raw material availability. So those kind of scenarios we can provide a data to AIML model, and it will give us the predictive solutions which will be helpful to optimize our plant. Okay. And with the help of that AI, this executable digital twin is another terminology where we have a data, real-time data a source from the shop floor edge devices. We can execute those data onto the digital twin, where we can have a real-time monitoring and again alarms for the uh, failure or any action has to be taken onto the alarms. Those kind of thing we can do in the executable digital twin. So this executable digital twin will take those data as an input and calibrate himself to have a performance on next level. So that is where executable digital twin will work. And next part is industrial metaverse. So as I said, we are getting all those data maybe from digital and the shop floor data, which is a physical data, using those data to optimize our model or production processes, design, planning, all the phases in the manufacturing thing. Okay. And it supports like photorealistic rendering viewers, where you can visualize your factory as 1:1, where you can see in the real factories. Okay. You can assign the lighting, material, textures to those simulations, and which will act as a digital replica of your physical plant. Not in terms of only visualization, all data can be manipulated and provided to the virtual environment. That is a terminology called industrial metaverse, which is going to be a huge difference in coming years. So to just lighting on this metaverse terminology, how exactly it will work, like as I said, digital data, which might be your shop floor asset data, the specification of physical assets, okay, and then the real data, where we can have your quality specification parameters, your robot OLPs, PLC programs, and all. Okay, yeah, all those data will gathered. Okay, so we called in Siemens, we called it as an accelerator platform, where we gathered all the data. Okay, from shop floor, from digital tools like a simulation tool, design tool, or your manufacturing execution systems. All those data will take into the accelerator platform. Then it will create a global scene. So as I was talking about photorealistic rendering, so it will create a scene or the viewer where you'll have your factory digital replica, which look like a real by using a photorealistic rendering platforms like Omniverse. So we had a tie-up with NVIDIA Omniverse, which is a realistic, photorealistic physical simulation engine. Okay, and we'll add one more dimension to it called time. So time frame data we are taking from digital and again physical assets, which is going to implicate on this global scene, which might be for particular station, line, or whole plant, or you can visualize the plant from different geographies also. Okay, and the data is coming from the shop floor or the digital tin, maybe uh, gathered, analyzed, and then implicated onto the top of this global scene. Okay, so this is the next dimension, and again the data relationship. So whichever is the relation between your robots and PLC program, might be some IoT data which going to affect your performance of robot or the machine. Those relationship we can build with the help of this AI modeling, and then predict the failure of those assets, your processes, or maybe line. By using all those three parameters and AI services along with this, we are creating the industrial metaverse experience with the help of different partners like AWS, Microsoft Copilot, and the NVIDIA Omniverse, which is a viewer or the realistic, photorealistic viewer in this case. So by using that, you can monitor at any point of time assets of your health of your asset, monitor the operational parameters of it. If there is any failure, you can address those failure by using different errors, and AI will help you in that case. Again, you'll get a predictive maintenance strategies if it is going to have a maintenance. You'll get alarms or notification on top of it. So this is the call. This is the future of the digital manufacturing, which I can say called it as an industrial metaverse. So AI is one of the part of it. The thing how it works. So this is our real production line or plant where we can collect the data by using the uh, tool called MindSphere. Okay, so we have this tool where you can collect the required data in terms of time series data or the live monitoring data with the help of MindSphere tool, and then stream data streaming will happen in this tool, which has again a uh, supported with AI capabilities where you can provide this data to learning for the models. Okay, and by using those data, we can provide those data to the digital replica of this model. So this is tool called plant simulation. So something similar can be done with the process simulation also. So what are plant physical plant data, you can collect it and run those data on the virtual plant. So we call it as a replay of that data. So wherever your bottleneck is happen, it will get identify in the virtual plant. Okay, and then corrective actions will be taken care in the virtual environment. Some strategies or what if scenarios can be run here. So maybe for example, like only one robot is using for palletization. It is creating a bottleneck or accumulating the number of cartons at that particular station. So in virtual environment, you can create one more assets uh, to do the palletization, and if it is clearing the bottleneck, you can suggest those type of decisions to the real factory, which will minimize your resource burden and improve your throughput per day or per shift in that case. Good. So this is just one example. By that way, you can do the throughput analysis, bottleneck identification, Then you can do different what if scenarios if you have to increase number of material handling equipments like AMR or AGVs. Those kind of scenarios you can run, calibrate your model, and after like identifying and fulfilling the demand throughput in virtual model, you can give those suggestions to the real production plan. Okay. By this way, you'll utilize the AI capabilities, yeah, utilize the real data to train your AI model, and then calibrate your virtual model to take a further decision on optimizing the processes. So this is the use case which I was talking about, where you can take a feedback from uh, plant, okay, which might be a like MTTR, mean time to retrieval, mean time between failures, okay, and performance design improvement using physical, like precisely calibrated model with a higher level of confidence. So initially we have a virtual model, which is an experimental basis. And once you get the data from the shop floor, you are calibrating those data, which is making that close to real world. By doing that, you can do bottleneck analysis using plant floor data, become powerful tool to identify the constraint, which might be your station constraint, asset constraint, and then you can create strategies to overcome those bottlenecks. Then diagnostics of different processes which might becoming the hurdles in your throughput increase. So you can identify those, diagnose, and take action on it. So one more thing, predictive maintenance. So as in the real physical plant, we'll have a data about the last calibration and the tool wear and tear data, might be number of RPM for those tool data. So that can be taken, and then predictive maintenance strategies can be decided into the virtual model, and same thing can be given to the physical assets. Another one is monitoring. So you can monitor the asset health, monitor the energy consumption of that particular asset, which might be a robot, special purpose machine, or any supporting devices like material handling equipments. And all. So by monitoring that, optimizing it, the consumption of energy and resources, you can increase the KPIs, which is decided for the growth of the company or the organization. So this was a thing how we can do that. So uh, like how we can optimize the thing. So to optimize that, these are the tools which we are going to use. So this is the actual topic which we are going to cover in detail. So solution overview to do the metaverse or digital twin, which will be helpful to optimize your throughput, optimize your robotic processes. Yeah. In as a leading digital industry software organization, we have a tool called Tecnomatix. So Tecnomatix help organizations or the companies to make their digital transformation, which might be from like brownfield project which is already existing, or if they wanted to set up a new plant. In that case also, this tool will help them to create factories or future factories from scratch, okay, which will be well in advance, identify the capacities and capability of those factories, which will suffice the requirement of the future demands. So process simulate is one of the tool under the Tecnomatix umbrella, where you can do the detailed robotics simulation, which supports different AI-driven robotics platform, which allow different partners or which has an open API to integrate with the custom robotic application, which is like vision system or bin picking algorithms, or maybe in case of micro fulfillment center or the e-commerce warehouses where you can integrate those robots with the warehouse automation system WMS, and you can increase your efficiency in terms of uh, material process flow or the delivery process flow. So I'll go ahead with this tool capabilities and how it will help us to bring our robotics or what we can say a digital twin in terms of real to close, where we can do all the things in virtual environment, and then we can take those data to the shop floor with the minimum configurations and all. So at that, by utilizing this tool or this what we can say technology, you need not have to disturb your production shop floor. You are doing all those things in the virtual environment, validating all the robotics processes, paths, logic, offline programming, your human activities also you can validate here in virtual environment. Then PLC logic also can be validated. And then just you need to take those robot program, PLC program to the shop floor, and with the minimum dry run, you can go live with your production. So what exactly this platform look like, I'll just put some highlights on it. Okay. So as I was saying, we have from end-to-end solution. So from conceptualization stage or planning stage to the design, then layouting of your plant and floor, then material optimization, as I was talking about the bottleneck and throughput analysis. And then the part come here, ergonomics engineering. So it might be a human ergonomics, it might be a robotics ergonomics, because we need to consider the robot optimized path with the collision free trajectories, and with the like uh, we need to work with different robots and machine interface. So robot has to talk with machines and other robots. So those kind of robotics engineering also involved in this tool. And the next part of it, like once you have a validated robot parts, you can integrate that with the automation layer of it. So you can connect it to the PLC, which might be a soft PLC or hard PLC, and you can validate those logic in a virtual environment without any physical assets. So by that way, you have your entire product life cycle in virtual environment. So you need not have to worry about physical prototyping, or wait for physical assets to come on your shop floor. Then you'll start commissioning. So uh, you need not have to do those inventory storage and all those things. You can do all those things in a virtual environment. So what this tool does, it will author the geometric modeling, where you can import different CAD format or CAD libraries, which can be from like different CAD tools. It supports a native format of .jt file, but you can import any file format with the CAD translator which it supports. Okay, then you can assign the kinematics to it. If it is well-defined robot, you'll get it from the library. If you're going to create some new gantry application or the new robots, you can assign the kinematics, validate those kinematics well in advance in this tool. Then again, you'll identify the operations which you're going to do with this in whole cell or line. You can create those operations. You can create a robot offline programs with the help of this tool. Integrate those robots with different machine, and your jigs, fixtures, clamps, end effector called grippers or welding guns. Okay, create a material flow from end to end. Then you can analyze the collision and safety factor of those robots, reachability of robot, because you need to place a robot at certain place where it will reachable to all the points which might be in your like pick and place of operation or welding operation or any of the robotic operation, okay, which will utilize your space effectively, and you can optimize your layout in that case. So once you have the optimized layout, you can run those simulation to calculate or to validate the cycle time, because to match the demand we need to fulfill the cycle time of that particular station. So it has to complete the process within this cycle time. So you can validate that, optimize that by bringing or optimizing the robotic processes. Okay, and you can integrate the sensors or different devices, actuators along with the robots, and validate entire process flow from process flow from starting to end of the line. So it supports a different application. So as I talked about the kinematics, reachability, sequence of operation, you can create out of that. You can create a different reports in the form of your HTML format or movies, or you can utilize a robot weaver or robot report generation tool where it will give you the robot energy consumption for particularly that operation, because it becomes a one of the factor to set up your factory, or consumption of total energy consumption of your factory. Okay. In terms of robotics, you can create a joints, the manipulation of joint. If you are going to create new robot, that also you can uh, create from scratch here. Okay, and validate those joint values, the link, the length, and all. Okay. For the existing robots, like from major robot makers like ABB, Kuka, Kawasaki, Universal Robot, the cobot from the Universal Robot. So you can bring all those things which is supported in this tool, where you can do the offline programming, trajectory planning of those robots, and you'll get the exact cycle time from this tool, where we can directly implicate those cycle time and the robot program onto the shop floor without any like hurdles. We did not have to do the manual teaching using teach pendant on the shop floor. This one is a VC called virtual commissioning. As I gave the glimpse of it, it will be the phenomenon where you can connect your PLC ladder logic along with the virtual assets, which is the process simulate tool, and you can validate your PLC logic with the virtual assets. So you can uh, decide the sequence of logic in PLC, signal communication from PLC to the process simulate, optimize those ladder program or the PLC program well in advance without any physical device. And then the human simulation. So not all the industries are having automated processes. So some of them having the semi-automatic or some manual processes like wiring harness assembly, or some of the automotive assemblies which is going to happen offline. For that purpose, we need to capture the human operations, which should be ergonomically correct. So we need not have to go overburden to the human simulation for particular work, because it is a repetitive work, and it create a fatigue for those human working on those assembly lines or the station. So we can validate those SOPs, which should be ergonomically correct, and suggest the optimized way to do that with minimum cycle time. So this is the capability of tool. Okay. I'll go some of the detail into the robotics part of it. So before that, I just wanted to know, is the space correct, Saroj, Dr. Saroj, or you will suggest something according to our participants?
Yes, Vishal sir.
Yeah. Yeah. Okay.
Huh.
So because some of them, I think, from academics background, to if need some detail, you can interrupt me and we can go ahead with question and answers also if needed. Okay.
Okay. Sure, sure.
Yeah. I'll continue. Then I think
Ah,
we'll take, if required, the questions.
all the participant, if you have any question, please raise your hand. I will allow to speak you.
Okay.
Participants, do you have any question? Please raise your hand. I will allow you to speak. Sir, we can continue at the
Yeah.
last. Just one question has came, sir.
Mhm.
In the chat box, you can read.
One second. Okay, can you read it for me? I'll just try to give the answer.
Okay. In robotic ergonomics,
Mhm.
is there human ergonomy included?
It has a two different modules. So where like it's application perspective. Some of the industries they're having mostly manual processes. For them, human ergonomic is the module which we are providing, and wherever robotics, most of the robotics processes are there. For them, robots are there. And if there is combination of both, they can have a both module and it will work together. Okay, hope I answered the question.
Yes, we can proceed further.
Okay, yeah, we'll go ahead and then I think at last we'll take the questions.
Yes.
So, specifically for robotics, like, are you all are aware about the offline programming? So, initially, in conventional way, still some of the industries are doing that. They'll go on shop floor, take a teach pendant, and teach the robot to one point, and then validate the logic and cycle time for that particular robot operations. But in the advanced tool and technologies, we can create those offline programming in virtual environment. We just need to bring the exact robot model, which this tool will support process simulate, because we had a tie-up with major robot makers. You can bring that robot, you can create robotic paths out of it. Okay, you'll assign the controller which is a realistic controller for that robot, and it will give you the exact trajectory path which is going to create from the teach pendant. Okay, and you can bring that robot program from the process simulate and directly use it into the shop floor. So by that way you need not have to have a physical robot in advance. You need not have to go on the shop floor and teach the robot using teach pendant. You can fine tune all those things in the virtual environment itself. So it will be a reliable cycle time prediction, minimum line shutdown time, because we need not have to stop the line because we are doing it in a virtual environment. And whatever feasibility or security quality gates will be checked in the virtual environment itself. So is there any emergency stop or sensors integration from the shop floor to the robot program, that can be done in the virtual environment itself. Okay. So these are the models actually. So as per the requirement, you can do the spot welding application, which is mostly used in automotive industries for BIW application to weld the body side door panels or your rooftop onto the body chassis. Okay, then handling and palletizing, wherever pick and place palletization or material handling applications are there, at that time your pick and place operations can be done. So this tool will give you the uh, templates. So as I said, it's AI driven tool where you'll get the automated template for spot welding, for pick and place operations. You just need to give a starting and end point, so it will create a path for you. Okay, and that path, again, by using the automatic path planner algorithm, you can optimize that path. You have to just give the surrounding objects, it will create a path without collision and with the optimum cycle time. Okay. Similarly, for arc welding and continuous applications, it will have a model. It will create a template. You just need to give a polyline along with which you want to do the continuous welding. Then drilling and riveting operations for aerospace or uh, aerodynamic applications. Then painting and sealing for different kind of automotive or sealing operations will be happen for profile, which can be for your front uh, glass and back glass of the automotive to place and fix it onto the car body. Then safety robot manager, as I was talking about, the industrial robot should work along with the fencing. So if there any human intervention in that fencing area, robot should stop immediately by uh, getting those signal from the door or the fencing light curtain. So all these features is already there in this virtual simulation tool, where you can you'll simulate 1:1 scenarios which is going to happen into the shop floor. So by that way you have you'll get a offline program which is fine tuned with the exact or validated cycle time, with the safety feature already checked, quality gates are already checked into that. So by that way you'll get all the fine-tuned robot programs. You can take that robot program and directly feed it to the robot controller on the shop floor, and it will work in vice versa also. So if you have already running factory but you wanted to optimize it, because we have seen the factories which is from 2 3 decades they are working with what we can say bare minimum efficiency, and they wanted to uh, uh, do audit and increase their throughput and efficiency or utilization of their resources. By that way you can bring all the robot program from shop floor to the virtual environment, fine tune this program, and again give it back to the shop floor for the optimized usage of these robots. Okay. Then again I'll go to the human simulation part of it. Though it's not part of our today's agenda, but how it will significantly affect the production or the manufacturing processes, that just I was trying to tell. Because whenever we set up the factory, uh, it's depend upon the geographical locations, and the operators or the human resources available for particularly for that geographical locations will matter while designing your plant stations or the processes. So this tool will support you to create a different human mannequin or on the basis of your anthropometric data, gender, ethnicity, then your weight and age. So it affects overall production processes and throughput of your factory. So by that way, you can create a workforce with the particular parameters and try to utilize them in terms of the actual processes going to happen on the shop floor. So this tool can create a simulation with the help of this human mannequin, which we have created on the basis of anthropometric data, which is region wise. You can see this lady is performing some operations. So the assembly line which is created in Australia will not suffice, or as is can be replicated into the China because of height difference or the reachability or operator vision envelope or work envelope. So all those things can be taken care into this tool, where you can analyze the operator reachability, its vision envelope, its work envelope, okay, and then identify the processes where need to be some of the what we can say changes or platform has to be given to the operator, or some of the raw material bins has to kept within the eyesight of the operator. So all those things you can identify and make changes. It will impact into the overall production timing or cycle time of your factory. So by doing this, you can fastly create a ergonomical assessments, because if it is reachable or if operator is bending too much, so by that way you'll identify those critical processes, okay, and try to change according to the application. So on top of that, it supports a VR technology, as we all know in immersive environment you can immerse ourselves into the virtual world and perform some of the activities which will be used for training purpose, because without having any physical product or assembly station or the plant, you can train your operator, create a standard SOPs by uh, creating the standard work instruction with the help of this VR tool and human simulation tool. Okay. So we can collaborate, simulate extremely fast. So it supports HTC Vive head-mounted display, where you can immerse yourself into this virtual world. Okay, easy to use applications and low investment. So you need not have to create a data for it or any expensive hardware for it. So it supports with the gaming VR HTC Vive minimum hardware. Okay. And again, as an advanced technology on top of this VR, it supports motion capture technology, where you can wear the motion capture suits or sensor on your body, okay, perform the activities which is dedicated to that operator, and we can analyze the uh, different ergonomical regulations by using this motion captured data, which might be your NOAAs or your fatigue analysis or your back pain analysis, ruler analysis. So you can capture those data, run the different analysis. It will generate a report. Tool itself generate a report out of it and give you the scoring of that particular process. If your bending is within the threshold limit, it will give you the green score or the card limits. If it is out of the threshold limits, it will give in the red color. So by that way, you can optimize your processes ergonomically. Also, if there is any wasting movements, so if operator is bending too much or walking two step to get some raw material in the assembly line, so all those things can be identified and eliminated to increase the throughput of your factory. We can see this is how we can wear the suits on the body and head mounted display, and whatever action we are doing in the real environment, which is implicated onto the virtual mannequin, virtual human operator in the simulation tool. By that way, one is to one assembly processes or work instruction can be created out of it, and which will be used into the actual shop floor. So not only in industrial use cases, it is getting used in different medical industries, sport industries, again your textile industries. So it's useful in multiple industries. So as I was saying, we can create this VR sequencer. Okay, by that way you'll have the instruction on your HMD head-mounted display, and operators can be trained by using this SOPs without any physical plant present into there. So by that way you can have your skilled worker well in advance available for your factory operations. You can communicate process across the team. So if there is a change in any SOPs, you can create a VR conference and it can be circulated along the teams. Okay. So easy and fast creation of VR sequence or tutorial for the operator training. So it allows us to create those VR sequences. This is again a physical aspects of the objects. You can assign the physics to the object where it can be act as actual physical object. If something drops, it will go and hit the ground. Again, we need to create a new operation for it. So all the scenarios which is going to happen in the shop floor, by using this virtual environment, we'll try to capture that and create as much as real to the as much as real replica of the real factory, physical factories. So by that way, we'll have close to reality. So it's not a just simulation or animation. We can simulate one is to one scenarios, which is going to help into the building digital twin of that physical assets. And these are the regulations or the ergonomic standard it supports. EOS, then fatigue analysis, strength analysis you can do, then force-based postures. So if you have to push something or lift some of the weight, those force solver also can be used. Okay, energy expenditure, then physical damage demand report. If some activities are going to happen for 8 hours repetitively, how your physical how your body react to that fatigue or repetitive actions, those kind of report you can generate here. And as I told about rula, neosh and ovas analysis can be done. Okay. Some of the examples are here. So you see here, you can see what operator can exactly see. If he's loading some of the things onto the fixture, then starting the operation. Again, lifting some other objects and going to load onto the fixture. So here you can track his postures, different joints, the lower back, ankle, or elbow joints, and capture those data and create a report out of it. So such kind of reports you'll get. And these reports can be again visualized by an ergonomic expert and suggest best practices for this. This is a human simulation. Then I'll come to the virtual commissioning part. So due to crunch of time, I'll try to cover the things which is more relevant to future factories or the to increase the efficiency of factory by using these advanced technologies. So virtual commissioning is one of the thing out of that. So where the conventional commissioning or the factory operations will work in the parallel, sorry, series process where mechanical engineer will design the fixtures or the machines or the parts. Then electrical engineer will decide the number of sensors, the sensor positions, or the actuator. Then robot programmer will program the robot by using teach pendant, and he'll try to integrate the sensors signal to the robot program to work it effectively. And then last part is the automation layer where automation engineer bring all these sensors, actuator, robots together and create a sequence of logic in PLC where it will trigger the actual assets. Okay. So by doing this conventional way, there is a communication lag between different departments. So again, whenever there is a problem, it will again go into the iterative process. Then blame game will happen if there is a issue at last moment. Automation engineer will say this design is not proper, or sensor was not at particular locations and all. So it will eventually delay your product launch or the production target which decided by the management. So, and it will impact your business overall efficiency in that case. So to avoid that, this virtual commissioning terminology or phenomenon came, where we, instead of having that in series, uh, without any physical assets, or in conceptualization stage only, mechanical design engineer can design the grippers, fixtures, robots, or special purpose machine. They can work along with the electrical engineer, where tool supports the sensor positions, creating different sensors, uh, assigning those sensor signals with robot, then automation logic. So by that way, all interdisciplinary department can work together without any physical assets in virtual environment itself. Fine tune their robot program, fine tune the mechanical design. If someone has suggested this is colliding with the robot gripper, so mechanical engineer will fine tune that design, change some parameters, and again send it to the robot programmer to validate the robot program. By that way, in virtual environment, you'll have a fine-tuned robot program, fine-tuned PLC program, and the material flow is tested well in advance. Okay, so at the time of commissioning, you just need to bring this robot program from virtual environment, put it into the actual robot controller. Similarly, PLC logic also you can just bring from the emulated PLC, which is fine-tuned and validated in virtual environment. Just put that into the hard PLC, do dry run, and you're ready to go live. So you save the last moment rush, uh, any blame game, and any damage to the physical assets, because we are doing all quality checks or emergency or safety signals checked in virtual environment. So you need not have to worry in the physical assets. So once you have physical assets, you can directly start doing the production out of it. So this is the advantage of virtual commissioning, which this tool, Tecnomatix tool, will support you. So it has a capability to connect with different PLCs, which might be from Siemens or different PLC makers like Rockwell, Mitsubishi, and it supports the OPC UA protocol, which is an open source where you can uh, connect to any OPC server, and this simulation tool can act as a OPC client where you can have a signal communication, bidirectional signal communication. So you can see here the signals. So here in this video, they've used the Siemens PLC. So and PLC Sim Advanced, which is a virtual emulator of PLC. So you need not have to have a hard PLC also, or what we can say the hardware PLC. You can create a program in soft PLC. You can compile that program and download it to the emulated PLC, and by that way you can connect it with the virtual assets, where these things we were doing in conventional way on the shop floor with the physical assets and physical hardware PLCs. So all those things you can do in the virtual environment. Here you can create a virtual HMIs also, test all those logics, the functionality of the devices, robots, then interactions between the robots and machineries and end effectors. You can see here auto run or clamp closing, opening from the PLC logic will happen into the virtual environment. So by that way, you have a virtually validated process flow devices, robot programs, and PLC program. So you're just ready to go with the live in directly the production environment. So this is the advantage of it. It's fully tested control concepts, robot programs you're having. Uh, at the last moment, you have less bugs or very what is a minimum trial and error concept is erased here, and you can just work on the fine-tuned robot program for the direct delivery. Okay, so it will eventually it will shorten the shop floor commissioning time. So which was the major part in terms of factory uh, setting and factory automation, because if you need to set up the factory, some of the commissioning or PLC engineer has to travel there, and they will do 1:1 program for the entire devices, and then integrate those devices and create a whole program. So all these efforts of resources and the human resources as well as the factory resources can be optimized, and all those things can be done in the virtual environment well in advance. And there is two ways to do that, as I was talking about the software in loop, where you can connect the emulated PLC with the simulation tool, okay, and validate your logic. Another one is a hardware in loop. So you can connect the hardware also, hardware PLCs or real PLCs, which doesn't support OPC or another protocol. So you can connect that into the hardware in loop with the Tecnomatix tool and validate your logics. And similarly, we have a tools of like in industry, there is a different tools available to do the virtual commissioning on component level. Okay, then machine level, if it is a uh, mechatronics involved into that machine, then cell level or the what we can say station level, where you have multiple robots with different devices, which might be conveyor, jigs, fixtures, grippers, and different machines. So those kind of virtual commissioning again you can do. Okay. And then a line level, where a line level or plant level, where you can do commissioning for entire plant using a plant simulation tool. Okay, so there is a different tools to do different level of commissioning in the virtual environment. So that is a virtual commissioning part of it. So I think at last I'll try to cover this Omniverse, which is again a part of metaverse, which I talked initially. Okay. So recently, we like you might have heard about the Omniverse or OmniLab, which is a GPU-based simulation engine, which is physically accurate simulations or real-time scenarios you can simulate into the Omniverse. So Siemens has a tie-up with the NVIDIA Omniverse, where you can whatever simulation which we saw in the previous slides can be directly connect to the Omniverse by using this Omniverse connectors. By that way, you'll have a photorealistic simulation, which will feel and look like real in case of your real shop floor images or shop floor scenarios. Okay. So this is one of our customer called Fryer Batteries. They are a Norway-based customer, Norway-based company, which is going to manufacture the EV cells or batteries for electric vehicles. So this is their future factory. So without having anything on the shop floor, we can create these future factories, which here you can see the 1:1 assets. It's a mixing process for them. So for battery manufacturing, mixer is one of the critical process. Okay, so you need to mix different reactors or the metal coating powders. Okay, all those parameters you can simulate here, optimize those parameters. Okay, in the digital world itself. Okay, and this is a simulation tool called sim center, which will try to give you the predictive or quality of that mixture in the virtual environment. So by that way you'll get a cycle time to run that mixture, and then you can replicate that thing into the actual plant. Similarly for robots, the robot energy consumption, robot cycle time, the status of the robot, or the health of the robot. If there is need to change any specific motors, arm, those things can be done in the backend in virtual environment itself. And how we can create a digital walkthrough of the factory also. Okay, this is a backup generator. So as I was talking about the energy consumption, to run the factory for 1 month or three shift, how much energy it will consume, how much CO2 it will produce, to track the sustainability or to have the sustainability goal in the overall factory setup. So we can do all those things in the well in advance in the virtual environment. So this is the battery cell assembly line where you can see AMRs are moving, and some of the battery packs get assembled onto the AMRs with the help of human simulation as well as some robotics operations needed. So we can create different KPIs. Your weekly demand is fulfilled or not, or is there any advancement needed into the SOPs? All those things can be done in a virtual environment. Okay. So by that way, you can like create a future factories, validate your processes, utilization of resources, and it will help uh, to take a decision for management authorities. So we can invest into these factories. By investing this much, we'll get these ROIs, or we are going to uh, make or produce this much units per year or per month with the with the help of this virtual simulations. Okay. So, so So by doing this collaboration, the strong simulation along with the robotics capability, Siemens has a tie-up with the NVIDIA where it leverage the photorealistic rendering part of it. So you can see the robots and their guns. They are looking like real, close to real, which is exactly can be seen into the shop floor. So by that way, for visualization purpose, to do the digital walkthrough of the factories, this tool is very useful. So this is a Tecnomatix viewer, and once we connect with the Omniverse viewer, you can assign the material. Okay, you can assign the lightning and fine tune those visual effects of rendering part of it. Okay. So by that way, you'll have photorealistic simulations of your factory. And similarly, one of the use case which I wanted to highlight on this. So once you have your object or the parts on which you wanted to do the operation, which might be a welding operation or pick and place operation. So by using this photorealistic rendering part, you can train or create a synthetic data of that object from different angles or different lighting conditions, and feed those data to the AI algorithm, and which will give the robot as an instruction to, if you find some kind of data, you can pick that part and place it to the different locations. So those synthetic data can be used to train the AI models for robot operations. Okay, and in future it will be going to more powerful by using all these tools to take a decision by their own. Yeah, I think here I'll stop my like presentation or talk on this topic. If you have any questions, you can take those questions. Yeah, Dr. Saroj, I think we can open the forum for question answer, or if they wanted to see some more thing, we can show that also.
Hello, sir. Uh,
Yes, yeah,
sir, actually, Dr. Saroj is busy in another activity,
okay.
so he got a call from Vice Chancellor. So, participant, if you have any question, you can post your question in Q&A box or in the chat box section.
Ashutosh is there, sir. Now I am back.
Okay,
Oh,
okay, sir.
Ashutosh, can you please ask your question? Unmute yourself.
Am I audible?
Yes,
yes,
please,
yes.
please, please.
Good afternoon. Good afternoon, sir.
Good afternoon.
Vishal. Actually, whatever you have presented is very nicely put, and it was explained very nicely. I am very thankful to you. I have one question only. So
Mhm.
this simulation in virtual reality you are giving to some of the companies,
Right.
and also when it goes for the real factory.
Mhm.
So when based on these simulations, the
Mhm.
real factory things are set up. In
Mhm.
that case, is it some different differences there when in reality they are setting up and your simulation is there? So what may be the difference in reality
So,
and
mhm.
simulation?
Yeah, I'll try to cover this question. So, whenever there is a greenfield project, so there is very like greenfield means new project, new factory has to set up. So most of the industries are going through this digital twin, what we can say, pathway, where they'll create all the thing virtually. Okay, and it will as close of 98% to the physical. Only some of the things which will be a building construction, or some of the uh, physical assets like operator availabilities or the human resource availabilities, all those 2% of difference we can say into the real factories. Okay,
Correct,
but
correct.
whatever 98% we have validated for assets, like we can suggest the robots or machines from the simulation itself, because it will going to work as is, which is done in the digital format.
And this is cost effective also.
Yeah, yeah. So
Yeah,
instead of doing trial and error, or uh,
yeah, yeah, definitely.
after investing you're going to know, okay, this will not work or this will not produce as our demand. So again,
Obviously.
mm,
Yes,
so
sir. Yes.
virtually you can validate. And by doing this, your board members or the investor into the organization, they are very confident to build
Mm,
those factory and invest
correct.
that much amount in it.
Absolutely. So you are saying only 2% is difference is there.
Right,
it,
for
it-
greenfield project. Yes.
yes, yes, yes. Right. Thank you.
Thanks.
Sir, another question in chat box.
Mhm.
One participant is asking, sir, is there any certification program is available in Siemens on this topic?
Yes, there are certification program for this.
Yes.
Okay. And for universities, if like I think I assume most of the our audience is from universities, so it has some free trial licenses also for academic purpose. So there you can explore these tools and then have the certification after exploration. Okay. You can get a trial license also in that case.
Another question one attendee is asking whether digital twin is applicable in robotics.
Yes, it's applicable in robotics. So if you see like universal robot, so whatever we are doing in the simulation environment, if we move the robot in real time, it will move into the shop floor. So by that way, you need not have to go and do teach pendant. Okay, in virtual world, you can do the teach points or the robot program. Okay, and that will going to replicate into the actual robots.
Yes, Dr. M.S. Divakar, please unmute yourself and ask the question. Dr. M.H. Divakar.
Sir, so good afternoon.
Good afternoon.
Sir, so this is Divakar, sir. I'm into robotics AI department.
Oh,
So, we have started one robotics AI lab, sir, with collaboration with some company.
okay.
So it is in the pipeline, sir. It is happening. I am interested what AI infrastructure that may be provided for them, since I need to set up.
Huh, huh, okay.
What AI infrastructure they have mentioned some AI infrastructure. What all that we may have to provide, sir.
AI infrastructure you're talking.
Yes, sir.
Right? So there is two things here. One is a software part of it, and another one is the hardware. So
Yes, sir.
in case of your hardware server, it will be a high-end server needed for this kind of virtual digital twin
Yes, sir.
simulations to be run. So it may be i9. So I can share the details into the chat also with server. But
Please, sir.
just for your like knowing purpose, i9 and then 64 GB RAM. More than that is needed for everything. So because
Yes,
it
sir.
will handle your PLC, then robot programs, and again photorealistic rendering softwares. So
Yes,
it
sir.
needs a high-end GPU with like NVIDIA graphic cards, RTX 6000 and more than that.
Yeah, we have proper automation studio and all the software, sir.
Oh,
For
okay.
that, we require, I think, as I said, we require more high end. I have proposed latest software like this, sir. Since I was not aware of the latest hardware that is
Oh.
good with graphic cards.
Hmm.
Yes, sir.
So most of the industries they are preferring NVIDIA RTX 6000 and above. So because
Okay.
they support AI like learning algorithms also. So in future, instead of going and upgrading that, initially only if we invest more, that will be helpful.
Thank you. Thank you so
So,
much, sir. Thank
yeah. And software part of it, you need to have a licenses. I think as you told, in case of Siemens, this is a tool called Tecnomatix. So Tecnomatix licenses you need to have. For academics, I think it will come as a bundle. So you'll get one academic license with all the features. I think Aniket will help in that case.
you. Sure, sir. Sure, sir. I think you can share me that certification course and also that we can also have some collaborative certification courses with our institute, sir.
Sure, sure. I'll share that.
Thank you so much, sir. Thank you, sir.
Thank you. And it is very good initiative, Divakar sir. So most of the IITs, NITs, and then our most prestigious institute, IISC, Indian Institute of
Yes, sir.
Science. They also have this robotics lab and smart manufacturing lab.
Yes,
So
yes, sir.
it's very good step towards the future digital manufacturing.
Yes, sir. Sir. We are planning for it, sir. Ours is a constant college of VTU, Belgavi, Karnataka.
Oh, okay.
So we are working on it, sir.
Nice to hear that.
Thank you so much, sir.
Thank you.
Any other participant would like to talk to the expert? Please raise your hand. I think no one is there, sir. Thank you so much, Vishal sir, for your deep in the knowledge and for your for sharing the thoughts with the participants. It was wonderful session. Thank you for the joining us on this webinar. Thank you
Thank,
so much once again.
thank you for giving me the opportunity.
Thank you, Vishal, sir. Thank you, sir.
Thank you all. Thanks.
So now we are closing the webinar. We will meet again at 2:30 p.m. with the another session. Thank you so much. Thank you, Vishal. Thank you.
Thank you all. Thanks. Have a great day.
Thank you.